Hello students, let's talk about a very important reaction from which one question or two question definitely comes in your entrances exams, and that is ozonolysis of alkenes. Now I will tell you the very basic mechanism of how the ozonolysis proceeds. After that, then I'll tell you the trick how to write down the products of ozonolysis the moment you see the question. Right. So now what is an ozone? Ozone is an O3 molecule and the structure is like this. Now this pi bond shifts here and the double bond, the positive sign which it has gets negated by the incoming lone electron pair from this bond. So this becomes neutral. This oxygen gets a positive charge since its bond has been taken away, and this is like this. So this is the structure which reacts with your alkenes. So now for example, let me take an example like this. This is my alkene. Right? So when the reaction starts, let's say the bond has broken. So if whenever the bond will break, it will have one of the carbons of the doubly bonded structure will have negative, and let's say this one gets the positive charge. So now what will happen when you will treat it with your ozone molecule like this? What will happen? The oxygen with your negative charge will go and attack the positive carbon, and the oxygen with positive charge will go and attack the negative carbon. So the structure or the product that you will get would look like this. Right? This is a slow step, which is also your rate determining step. Right? Now this is called as ozonide, and it is very unstable. So now what will happen? This will undergo rearrangement and it will have a structure like this. What has happened? This oxygen has gone above with a little rearrangement, and this is a comparatively better structure in the terms of stability that it has. This is called as ozonide. Right? In exam, you can directly have the trick that whenever you see an alkene, what you have to do is just take up one electron from here, because the ozone molecule is going to be added, and add them in the shape of a heart like this. Right? So you will directly have ozonoid in one step. Now what will happen, that when you will treat it with zinc and water, this ozonide will break, and it will break from here. So the moment it breaks like this, what you will have a CH3 CHO molecule plus a CH3 CHO molecule here. And these will be your products of ozonolysis. Now, instead of doing such a long mechanism, in entrance exams, you know, the time is the biggest asset. So you cannot spend so much of time in writing the entire mechanism just to write these two major products of your reaction. So what you do is, if you have a structure of your alkene like this, just break your double bond from here, add one oxygen here, add one oxygen here, and your product is ready. What has happened? It is CH3 CHO plus CH3 CHO. So the easiest way is you break the double bond and you add one oxygen on each side of the molecule. Example, let's take the simplest of the example. If you have an alkene, right, the entire procedure would be like this. You make a hut and then you break it once you treat it with zinc water, and you will have CH2O plus CH2O, right? CH2O means HCHO plus HCHO. This is your formaldehyde. So if you use the trick that I'm telling you, you will add one oxygen here and one oxygen on the other side of the double bond. Still you will get the same product that has been given. So if you have a subjective paper, you can go on writing the entire mechanism, but for your entrance exam, I will suggest you to do it like this. Now the most important question is, why did you add zinc and water? Why not just you do a normal hydrolysis? So the answer for this is, for example, I will do the reaction same for this. You added ozone, and after rearrangement you got your ozonide like this. And then if you add water, you get HCHO plus HCHO, right? Now, along with the two molecules of HCO, the other byproduct that is produced is your hydrogen peroxide. And we know that hydrogen peroxide is a good oxidizing agent, and it will oxidize your aldehydes and ketones, whatever the products that are formed in the reaction, to the corresponding acids. That means this will give you HCOOH plus HCOOH, your methanoic acid. So if you want to stop your reaction at aldehyde or ketone stage, you have to add zinc water. So this is also an important question from your entrances point of view, that what is the use of zinc, adding zinc in ozonolysis. The process, the zinc is added so that the process can be stopped at aldehyde or ketonic stage, and further oxidation is stopped. So if you do not add zinc, you will end up getting the corresponding acids instead of your aldehydes and ketones. Apart from zinc water, you can also add dimethyl sulfide. Now, what actually will be done if you are adding zinc for removing H2O2? Because H2O2 will keep the reaction till the corresponding acid stage. So if you are stopping, then that means you are removing H2O2 by adding zinc water or dimethyl sulfide. What will happen is, zinc will react with the peroxide that is present, and it will yield zinc oxide and water. So your peroxide is out of the picture for doing further oxidation. Similarly, if you use dimethyl sulfide, the peroxide that is formed will form dimethyl sulfoxide. This is a very important solvent in your organic chemistry, and water. So your further reaction will be stopped. Have a compound like this, an alkene like this, and you do ozonolysis and you do not add zinc. Now what will happen? It will break from here, oxygen here and oxygen here. What you will have? You will have a CH3CHO plus CH2O. But your reaction will not stop here, because there would be a peroxide. So eventually you will get an acetic acid plus a methanoic acid, right? What will happen if one of the product is a ketone? If just in case a ketone is formed, right? If a ketone is formed, then H2O2 cannot oxidize into corresponding acids. What it will do? It will break the carbon chain and the lower acids would be produced. That I will take up in another video. Now let's take few examples. For example, I have a compound like this, and ozonolysis is done along with zinc water. So what will happen? You will break it from here, one oxygen here, one oxygen here. So what will be the product? The product would be like this. The bond has broken here, one hydrogen was already there. Similarly, if you have let's say CH2 double bond C, CH double bond CH2, and here it is CH3. Now what will happen if you do the same process in the presence of zinc? So that means the further oxidation is prevented. You will break it here, one oxygen here, one oxygen here. You will also break it here, one oxygen here, and one oxygen is here. So you will have ultimately three products. The very first product is going to be HCHO. Here also it is going to be HCHO. What will happen here in this region? You have a carbon which is doubly bonded oxygen. You have added one oxygen here. This is CH3, this is CH, and there is a doubly bonded oxygen here. So ultimately you get CCHO, CH3, and a double bond oxygen. The reverse of the question can also be asked. The question here says there is an alkene X which on ozonolysis and treating it with zinc water, it gives you a butane 2-one and a propanone as the product, and you have to find what is X. For this, there is a very simple trick. What you have to do is you just write down the structures of the compounds first. So you have a butanol here, and at the second position you have this. So this is CH3, CH2, CH3, and this is CH3, double bond O, CH3. Now just the simplest trick is write both the products that are formed, that are given to you in the question, in such a way that the carbonyl group of both are facing each other like this. So if you write it like this, this ozone molecule can be removed, the oxygen molecule, and you can have, what will happen, this is this carbon, so you will have a CH3 here, a CH2, CH3 here, doubly bonded to this carbon because the O2 from between has been removed, and this will be CH3 and this is the CH3. This is the alkene that was used. You can do the ozonolysis of this particular compound to confirm if you are getting the same products. I hope the trick is helpful for you, and you will like the video and subscribe to my channel so that you can have access to more easy tips and tricks for chemistry. Thank you.